Hey guys, welcome back to the channel. Today we're going to look at this Signal Corps intercommunication station model LS124B. According to what I've been looking on the old doobly-doo out there, I figured out that this was probably made around 1955 for the US military. And basically what it is, it's an intercom system. It's got 12 channels. This would be a master, so you can, talk to... Boy, those are some nice clunky switches. I got one broke here, but oh, that is so disappointing. They were so nice going down and mush going up. Oh, alright. And then we got our, I think this is listen and talk. It's got, built-in speaker, built-in microphone. It's tube based, so 1955. They really weren't much into integrated circuits yet. That didn't come really later until the 60s. Yeah, let's spin this around and pop it open and take a look at what's inside, guys. And see, we got our output here. This just got 12 twisted pairs coming off of it. And I think there's a ground that's loose and I don't know, I think there was one extra wire, but there's 12 twisted pairs in here for each one of the 12 channels. So, and then yeah, 120 volt old school plug. I mean, this is the original Cornish plug, unpolarized, so if you don't plug this in the right way, you can make the outside of this live. So that's why we have plugs now with one side bigger than the other. Let's get a flathead here. Here's a flathead. Get these. Oh, somebody's definitely been in here. Right, but 2 screws holding the back on. I wonder if there's any tubes left in it. Like I said, I did some searching around there on the old doobly-doo, and I'm not really able to find this exact model for as far as schematics or anything yet. Oh wow. Okay, so we got our amplifier tube. Not really quite sure what these are yet, but yes, we are very dirty and dusty. Pretty sure the power supply is kind of built into the bottom. Got some old massive capacitors here. This is your main filter cap. Well, I wish that bracket wasn't in the way. We gotta get into the bottom to move it to see our pin out here. Looks like this transformer is for the tube, more than likely. It looks like it's putting 400 volts out, and then looks like a 4.5 volt probably for the filament. We got another big sealed transformer over here. Got our this is our big filter caps, more than likely here, just in an old tube socket. Yep. Got a, let's see here, 53F 200R, 20 microfarad at 450, 20 microfarad. Nice. I even got the hand painted positive leads on there. That's you don't see that anymore. And there's your pinouts. Wow. It's got some heft to it. Pretty sure that's gone. Okay, so another transformer here. These are old, I believe that's a capacitor. Wow. Pretty simple looking. And here you can see the back of our rotary switch. You know those are silver terminals. Looking at the corrosion on there. Yep. Very cool. Very cool. Alright, let's I really don't want to put it on the front. We'll put it on the side. Let's see if we can get this bottom off of here and take a peek inside of it. Really don't have any use for this in working condition. Moisture fungus proof 5.50. I wonder if they're talking about the paint, because there is no mold or no kind of nothing growing on it, so whatever this is coated with is probably really good for you. Most certainly causes cancer in California. Okay, here we go. We got just a bunch of reed switches. That's why we got the nice snap going down and mush going up. So yeah, it's almost like a bimetallic switch, but you know, you're not using temperature, you're, you know, just flipping the reed back and forth. That's really cool. Yeah, guarantee all these old electrolytics here are probably no good. Yep, these have all been impregnated with moisture. We'll have to replace those resistors. Yep. Yeah, these old, some of these old resistors, I believe like this one here, you see how it's got the rounded edge. These ones here are hydrophilic, and they will soak moisture from the air. Or so I've been told. I don't know, I really don't mess with a whole lot of tube stuff. The high voltage in them is a little scary, you know, having 400 volts going to a tube. You have to be very careful on what you're doing inside of there. And the capacitors that are in there just hold just unbelievable charge. So yeah, I mean, this is pretty cool. I almost guarantee if we were to plug this in, I almost guarantee it would work. Wow, this is really cool, guys. Let me know down in the comments. Oh wow, 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 whoa, hang on. We do have a schematic. Very nice. We're kind of losing some over here. Something looks like it's leaked in it. Not really sure which orientation this was. Maybe this way? No. I believe this rust and this rust match up. I went this way. So I really don't see that it was a capacitor leak. But yes, we have a full-on schematic here. Unless otherwise stated, all capacitance use microfarads. All resistance values, we're losing that. K equals 1000 ohms, 4 equals 1 million. S2 in idle position. Indicate voltage obtained 2000 or 20,000 ohm volt. voltmeter. Okay. Very nice. Very cool. Just want to be careful. I don't want to lose the schematics if I do decide to bring this back to life. But yes, that is very cool, guys. But yeah, let me know down there in the comment section if you want me to try and bring this back to life. On that note, I think we're